In today's video, we are going to work on unfamiliar mechanisms, which is quite a tricky topic. I'm going to do quite a few examples, and you may want to stop the video, try to do the example, then carry on watching. Some prior knowledge is that a covalent bond is a shared pair of electrons. AQA arrow shows you the movement of a pair of electrons. Let's see the first example. We have this balanced equation. We are going to see the mechanism. And what you are going to do is you want to form a bond between the oxygen and the hydrogen so that you get water. To show that formation of the bond, you would draw an arrow from the lone pair, always from the pair of electrons to the atom. And things that are good noticing is that the oxygen, which was negative, it's becoming neutral because it's losing one electron when it releases the curly arrow. At the same time, the hydrogen, which is gaining a curly arrow, is gaining one electron. So then it goes from positive to neutral. Second balanced equation, we are going to draw the mechanism. You want to give it a go, try, see what you get. It's really similar to the mechanism before. It's the same curly arrow, but because the oxygen is neutral, then when it loses one electron, it becomes positive. And the hydrogen is exactly the same. It goes from positive to neutral. Next example. This one, what would you get as products? The oxygen is forming a bond with carbon, and the oxygen is going to lose one electron. The carbon is going to gain one electron and one bond. So then you get the carbon with a new bond and a negative charge. The oxygen that was negative becomes neutral. Okay, let's do another one. This one. This bond is breaking and the electrons go to the chlorine. So the chlorine gains one electron, the carbon loses one. Therefore, the carbon becomes positive, the chlorine negative. And this one, what would you get? It's very similar to the first one, isn't it? But the electrons go to the carbon. So then the carbon becomes negative without, sorry, there's a mistake, without the lone pair. No, with the lone pair, because the electrons go to the carbon, it becomes negative, and the chlorine becomes positive. What do you think you would get in this one? The oxygen is making a bond to the hydrogen. The hydrogen to carbon bond is breaking, and the electrons go to the carbon. So the oxygen will become neutral, and the carbon, which is gaining one electron, becomes negative. The hydrogen doesn't lose or gain electrons. It gains a curly arrow, but it loses a bond. Okay, next one. What do you think we will get here? Similar a little bit to the one we saw before. The oxygen bonds to the hydrogen and becomes neutral. The hydrogen breaks the bond with the carbon, and the electrons now, they don't go to the carbon, they go to the single bond, and therefore it becomes a double bond. Now the chlorine, which is gaining a bond, becomes negative, and the carbon, which is keeping the same number of bonds, stays neutral. It is a little bit tricky. I'm hoping it's making sense. If you want to ask questions, please do in the comments. This one, what do you think we would get? The oxygen is making a bond to the hydrogen. The hydrogen-carbon bond is breaking. The electrons go to the single bond. So the oxygen goes from neutral to positive. Here, this bond is lost, and you get a double bond here. And then this bond is lost, and the chlorine is gaining the electron, so it becomes negative. Well, and I leave you this quote, which I hope you find it useful as well, maybe. And that's all from me. Bye-bye.